What's up, everybody? Welcome to another episode of Let's Ask Paul. My name is Paul Abernathy, your host as always, and welcome to the podcast where I, Paul Abernathy, that's me, answers your code questions that you submit over at the paulabernathy.com portal. Yeah, if you're not familiar with that, it is a free service that we offer through our corporation. It funds it. The corporation takes care of the expenses for me to answer these questions, the server, the hosting, everything's done. And all you got to do is go to paulabernathy.com, submit your question. It comes to us and we will answer your question either in an email or if they feel it's important enough to share with other people, then it will be answered in the form of a podcast. So thanks for joining me on this episode. Again, I don't know what episode we're up to at this point. I'm thinking we're up to episode 68 of this new series. Of course, if you want to listen to our hundreds of other podcasts or even watch our exclusive videos, then you can go over to electrocodecademy.com and you will see a members only button at the top. It's a tab. Click on it and you can join and become a members only. It's $9.99 a month. And you get access to all of our videos, all of the future ones, all of the past ones, everything. But you also get access to podcasts. We have hundreds of podcasts and all those type of things. You also get to listen to all of our podcasts from our app. So we have a free app you can download as well from our website, or you can go to necchat.com. That's necchat.com, and you can download it from there as well. That's just our download portal. And you can get the app and you can listen to all of it on your phone seamlessly, get access to any of our podcasts and things like that. Okay, so if you want to get that monthly subscription, go check it out. It is available over on our website. We look forward to having you as a monthly subscriber. You can cancel at any time. Or you can do the annual and just support us with an annual purchase of, I think it's like $119, which if you break it down, our swimming pool video alone, 8-part series, is worth the price of that. Our grounding and bonding 12-hour series that's in there is worth the price of that alone. So you get access to all future videos that come out. So again, something you're interested in, we look forward to that support. And of course, there's a lot of people that just do it on a monthly basis to show their support for us. Again, it's less than $120 a year. And if you feel that the content we provide is about the cost of one textbook, then again, we appreciate all that support. And that's what we get most of the people ask how they can support us. Just become a monthly subscriber or an annual subscriber. That's the best way that you can support this moving forward. So again, we appreciate everybody that helps support us. And again, I like to give back, and that's where paulabernathy.com, the portal, came from. Okay, giving back a little bit of that support. All right, so we're going to answer a question that we get today, and it's going to be probably pretty darn detailed. So again, if you've got your code books, it's probably going to be easier for you to follow along. If you have your code book. So again, doing your best to follow along. And I believe this one episode today is on the 2017 NEC. So you want to make sure that you have a 2017 edition. But I don't know that any of these are going to be significantly different from the 2017 to the 2020. I really don't. So anyway, let's go on and get started into this question. We'll start out with the basic stuff first. And then we'll move on to the code-related informations here. It says, I need to write a report for an insurance claim. I was brought in to document an air conditioning unit that caught on fire. Okay. They're claiming that the electrician that changed the panel did not wire it correctly when the new panel was installed. When installed, it was not inspected. Okay, well, that's the first problem. Okay, wasn't inspected, so there you go. I found several things wrong, and it was a blessing that they needed to inspect. It was a blessing that they needed it inspected at this point. I suggested they get a new electrician to fix the panel immediately and not wait until the insurance claim. Okay. At that time, I will inspect it again. I will write down the violations, but need to make sure I am using the correct code references. Okay. I always tell people, be careful when you get called in and you're going to be an expert in this, because it could come to litigation because of the fire and whatnot. So I'm usually a little guarded here because I have things that I do as a consultant for people, and that's, basically I get $325 an hour, minimum 8-hour day, $2,600. And when I do an expert witness on a case somewhere, which again, I'm available for people that want expert witnesses when it comes to the National Electrical Code, but that's my rate. And of course I have insurance, liability insurances. I have all this stuff in place for what I do, right? But at the end of the day, there's a reason why I have. So the reason I say that is because when you go in and do this as an electrician, make sure your insurances cover what you do. I know it might cover you as an electrician, but does it cover you giving this information, this advice, and consulting type of information? Just be careful. I'm sure you do and all that. So again, just making sure you cover all that type of thing. All right, and that means knowing your violations, understanding the code. And this is why I tell people all the time, it's one thing to be an electrician, but to understand the National Electrical Code takes a lot more dedication and commitment, right? In order to be able to do that. And you're not to me a fully competent, complete electrician unless you know how to do what? You know how to do code. Okay, so we want to make sure that we're approaching this from a code perspective, most definitely. All right, let's look at here. Let's see. So they're using the 2017 edition of the National Electrical Code. So we want to make sure that we have our 2017 edition handy when we look at this and give our opinion. Okay. So grab your 2017 and let's get it. We can start looking at things one at a time. Okay. All right. So first one, it goes here. It says, okay, main panel. Number 1, no grounding electrode found in panel 250.53. Okay, so let's do that one first. So no grounding electrode found in the panel. Now, just I'm going to help you out a little bit so we can kind of move through this. I think what you're saying is you found no grounding electrode conductor and you found no grounding electrode system. So not that we're trying to pad what you put in your report, but I always find that when you're giving an expert witness, expert testimony, your reference that you're making to 250.53, that is dealing with grounding electrode system installation when it comes to rod, pipe, or plate. And then, of course, supplemental, and it kind of goes on to that. And then it does have the water pipe and D and then blah, 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 G and ground. So, yeah, it's got all that. I think the question is first, is that it probably doesn't have any grounding electrodes. It doesn't have any grounding electrode system, right? So your real reference should first be 250.50, which requires a grounding electrode system, which requires the different types of electrodes that are followed into 250.52A through 8, right? A1 through A8. Now, we have to remember that you also have to look at this panel. When was it installed? So you'll have to do some history to go back and see that, it's been required to have the grounding electrode system for many, many, many decades. But there was a time in the rural old homes that they probably didn't have a grounding electrode system. And it's made it this far. Granted, if it was inspected at the time and it wasn't required at the time, again, I'm not going to give you dates because you're not hiring me as a consultant. So I'm not going to spend my time going back in history and trying to find when this first was required and then match it up to what the year of the house was and when it was inspected or installed. You didn't give me that information, and I can't really do that for you. That's something you have to do. I'm not your paid consultant. But if you notice that the house was built in the last couple decades, then it's required to have a grounding electrode system. So citing 250.50, which requires the grounding electrode system. Then you could cite 250.52 for the lack of the grounding electrodes, which would be whether it's ground rods, pipes, plates, whether ground ring, whether it's a metal underground water pipe, and it's supplemented and all that. That would be the lack of your electrodes. 250.53 is more about grounding electrode system installation, which, again, you could cite that as well. But I would say to supplement this, you should cite 250.50, 250.52, and then 250.53 subsequently in all of those rules. Okay? Because it kind of leads to all of the little pieces that's required to establish a grounding electrode system. Again, I don't know the year. I don't know when it was built. I don't know what the rules would have been during the time of when it was built, that type of thing. So I can't speculate on that. I'm just telling you, this is what we've got. And you have to remember that when you're doing an inspection, if something was compliant at one time and you're not messing with that, you're not required to bring it up. Okay, at least from the perspective of the National Electrical Code. Your jurisdiction may say differently or whatever, but that's general that one. Okay, so that's how I'd answer that first question. The next one you have here, it says a single pole 30 amp breaker was installed for a 240 volt disconnect. Okay, so I'm not sure I understand this one. We're going to try to pull out some of this information, but I'm assuming that it's two single pole breakers together and he didn't have a handle tie or something like that. I'm going to look at this because it does give a code reference, so we'll look at it. Because you couldn't get 240 from a single pole breaker, right? So I'm assuming it's just two single poles, 30 amps that are together. Now, they do give a reference of 210.4b, so we're going to go look at that so that we can make sure that that's the reference that you're referring to, because I'm going out on a limb, but we know you can't get 240 from a single breaker like that, okay, one pole breaker. So we're going to look at 210.4, which does kind of correspond with the multi-wire branch circuit application or whatnot. So got your code books. Let's go to 210.4b. And let's see here. Disconnecting means each multi-wire branch circuit shall be provided with the means that simultaneously disconnects all ungrounded conductors at the point where the branch circuit originates. Okay. Now you gave for B. I don't know that I would call this a multi-wire branch circuit. It's just a 240 volt branch circuit. But I get what you're trying to say with it and what you're trying to go. Now, I would say more of the aspect of utilizing breaker requirements and what your rules for that would be. So, and I'm not so sure I agree that that's the most accurate one for this statement, because I think the real one that you're really looking for is 240.15. And that would be B2. So B2 is talking about in a grounded system, individual single pole circuit breakers rated 122 40 volt AC with identified handle ties shall be permitted as the protection for each ungrounded conductor for a line-to-line connected load for single-phase circuits. So I'm thinking more that's along the line of the one you want to give a reference for. I don't know that I would call what you're talking about a multi-wire branch circuit. But in the scheme of life, at the end of the day, the 210.4b reference is really talking about the disconnecting means and simultaneous disconnecting. That's if you're going to be sharing a neutral, you have that kind of, and you got multi-wire branch circuits and things like that. I think probably to me, again, more accurate would be to cite 240.15. And that would be B2 in the 2017 NEC. I think that's more accurate. Now, you can put them both just to cover bases in case, you get into interpretation of what somebody considers a multi-wire branch circuit or whatnot. But that doesn't kind of correspond with our notion of what we think of as a multi-wire branch circuit. So it could cause confusion on your report. So I would focus on the one that's, to me, more accurate. And I'm assuming that your 240.15b2, or you said 240.4b, I think the 240.15b2 is trying to cover what you're saying about the use of two separate or use of a single overcurrent protected device, that type of thing. So I'm thinking that's a better reference for you. So hopefully that helps you out and gives you a little bit better reference for that one. The next one, it says, number 3, says the ground and neutral of 100 amp sub-fed wire not connected in the main panel. Okay, so this sounds like a situation where the remote distribution panel downstream, you do have to have that separation, right? And you're going to get all of that in 250.24. I believe it's A5 that requires that separation. But in the main panel, all of that's going to come together at the same bus, right? It's all going to be connected together. And basically, you're not going to really control that with the feeder. This is all done when you come in with the service conductors. This is all done when you bring the grounded conductor to the service and you do all those things that you're required to do in 250. That when you do that, everything, that's why you have a main bonding jumper. And all of those rules that you would follow in that are going to be under 250.24. A5 is talking about not making any load side connections. So that's why you separate it on the load side, right, downstream. But everything else, that you get in these rules are going to all come from 250.24 that requires the grounded service conductor to be bought to each service. And then A1 is going to tell you how, they're all tied together and do everything. And then, of course, you've got the rules for a main bonding jumper and sizing or whatnot in A4 and going to end up sending you to 250.28. All of that's conducive. It's the part that officially in the code tells you to separate these on the load side, and that is 250.24A5. So the requirement that you want to put for this one at the panel is you really want to cite 250.24A and 250.24A1. All of those rules are going to be what you're going to do. Okay. Let's see here. Really only the really only necessary reference that you would need for that. Well, the only other one that I would tell you is you can also look at 250.24C, which is the grounded conductor bought to the service equipment. Gives you some rules in there. It says the grounded conductor shall be routed with the ungrounded conductors to each service disconnecting means and shall be connected to each service, each disconnecting means, grounded conductor, terminal, or bus. Okay, and then a main bonding jumper shall connect the grounded conductor to each service disconnecting means enclosure. So it kind of intimately brings them all together, and that's what you need to do, right, in that service panel. And so you could very much reference also 250.24C for this application. Now, when you're going downstream to the remote distribution, if they weren't separated there, then you would just reference 250.24A5, okay? And then you could also reference, for craps and giggles, you could also reference objectionable currents, and that may or may not be arguable, but 250.6 says you have to arrange it to prevent objectionable current, and making improper case to neutral connections downstream of the service disconnect would create objectionable currents. Circulating currents create a hazard risk and things like that. So just some extra information, and hopefully that helps you out. But that's your reference for the grounds and neutral in the panel. Okay, have to be taken and bought together. So I would use 250.24 A1 and A, and then I would use 250.24C as well in order to achieve that statement. The next question is it says three wire that shares a neutral not connected to a double pole breaker, 210.4B. And then it says 210.4BD5. I'm not sure about your question. Hey, I always tell people, when you submit me questions, read your question first so that you don't make me have to speculate. Write it out and be very descriptive in how you do it. And over on our portal, you can take as much time as you want to fill it out. In fact, I recommend you do it in a Word document and then cut and paste it after it looks good over into the Let's Ask Paul portal, and then you can submit it. That way you know that the punctuation is as good as it can get and everything looks good. Even though it does kind of lump it all together, it just does make it easier for me to be able to read it and try to convey what you're trying to achieve. Okay. So on that one, I'm not sure what the question is. Yes, it's a 3-wire that shares a neutral. So assuming it's a black or red and you have a white, that's a multi-wire branch circuit. And that is kind of what you get of a multi-wire branch circuit. then yes, that would be the same reference as a multi-wire would be 210.4b. But also remember that you do have some rules for multi-wire brand circuits. You can also reference that as well. And the 240 reference that I gave you earlier. And for the life of me, I can't remember what that is. So I'll go back and look at it all because I want to make sure we give you everything we can give you. The multi-wire reference is 240.15b1 for that application. So you had the multi-wire, and then the other one was dealing with more or less just a 120, 240 volt circuit and how you would do two individual handle ties tied together with the identified handle tie. Same thing for a multi-wire. So I'm just giving you some extra references in 240 as well as what you're using in your 210.4b. Okay. The next one, it says ground of wire to a 50 amp stove not connected in the panel. Okay, well, that's a problem. Obviously, you have to provide an effective ground fault current path. Those rules, and I don't think you give a code reference to that. I believe you have a question mark on that. So the first thing that I would cite for that is if you go look, it's obviously a grounded system. You're going to go look at the very beginning of Article 250. And since this is a grounded system, you're going to look at it and you're going to see the requirements. And one of them is 250.4a. And you've got a couple in here you could use. Okay. A5 is the effective ground fault current path, which has to be established. And if your equipment grounding conductor is not connected, then you're not providing an effective ground fault current path. You're certainly not bonding electrically conductive metal parts together if it's not complete from the panel down to the load. Remember, it serves a grounding and a bonding function of an equipment grounding conductor. It even says that in the definition of an equipment grounding conductor. It serves a bonding and a grounding function. So you could cite the requirements in 250.4a, and if you wanted to be general without being specific, you can just put 250.4a, unless you're being asked to be specific. But again, it should get you where you need to be with that. Okay, so that's that one. And of course, if equipment grounding conductors, also you can obviously go into that part of 250, dealing with equipment grounding, and look at that, and that's going to give you some additional details that you might be able to utilize in your report if you want to. What I say, pad your report with extra code references. That's totally up to you. But if you did that, you will look and see that we have I believe it's part 6 of 250 deals with equipment grounding conductors, starts at 250.110. And you'll go through that and you'll get to the different requirements, types of equipment grounding conductors, yada, 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 sizing, identification, all this kind of stuff. You'll get there. So also 250.110 is talking about equipment fastened in place, fixed, or connected by permanent wiring methods. It says exposed, normally non-current carrying metal parts of fixed equipment supplied by or enclosing conductors or components that are likely to become energized shall be connected to an equipment grounding conductor under any of the following conditions. And then you have a bunch of following conditions down here, right? So, okay, so you got those different rules. So you could cite that as well in your reference. Just give it a look. See if that's kind of something that works for you. The next one you have says... Now, also I should remind you something. With that range, there was an allowance, okay, depending on when it was installed. Now, since it appears that a 4-conductor cable was used, and they just chose not to use the equipment ground, there was an allowance, depending again on when this was built, when you're dealing with it. One of the things that you would look at, just to verify, is in your code book, you're going to go look at something like 250.140 when it deals with frames of ranges and clothes dryers. And there's some exceptions to this rule here. So typically 4 conductors are going to go to ranges, 4 conductors are going to go to dryers, things like that, 240 volts with a needed neutral load. So you're going to have black, a red, a white, and an equipment ground, 4 conductors, just like you would do to a remote distribution panel. And you're going to have a separation of the equipment grounds and the grounding conductors at that point in the load, okay? Whether it's at the receptacle or what have you, just like we would do it at a remote distribution panel. But there was a time when it was okay to not have but 3 conductors, and basically the grounded conductor also serving as an equipment ground. That was allowed at one time, and only you will need to know if that was the case. But since you're saying a 4 conductor was installed, then this was upgraded at some time. And if it is upgraded at some time, then it's not an existing installation, then it would have been needed to be brought up to code. Okay? They just chose to not use one of the equipment ground in there. So that's probably not good. So again, that's going to be very dependent on the time, but make sure you look at 250.140 and look at the time of this installation and try to compare when it was done. And again, I can't do the research for you. You'll have to get somebody else to do that, or you're going to have to sign our consulting agreement, and I don't think you want to do that. So I don't have the time to go digging into history. Right? And but I believe this was in 1995 when this changed. Okay, don't hold me to it, but I believe it was then. Okay, what's next? Next one says connectors with no lock nuts, 312.5C7, holes in panel 110.12. Okay, 312.5C7, you're talking about the lock nuts. Now, you're required to secure cables to boxes, okay? You're required to do that, and here it says conductors with no, so connectors with no. So I don't know if that's a cable or not. So you might have a connector that connects to the cable, but it doesn't necessarily connect to the enclosure. And since this is 312.5, I will mind you something though. Be very careful with 312.5. Be careful with 312 in general, because if you're talking about a junction box, a panel, enclosure, general enclosure, or something like that. Well, I shouldn't say closure. Okay, let me redo that. Outlet box, junction box, device box, things like that. Then you're going to really be in 314, right? If you're in 312, and again, it makes me think that you're talking about maybe the connections to the cabinet where the panel is. Okay, if that's what it is, you weren't really clear on that. But that would be okay because 312 deals with cabinets, and your reference is .5 and C has to do with cables, and cable is where cable is used. Each cable shall be secured to the cabinet, cutout box or meter, socket enclosure. The item that you give us in here, you say, I believe you see C. Well, okay, that's not C7. That's just C in general. Then I would agree. If it's not connected to it and you don't have it, then it's going to be a violation and it has to be secured to the cabinet. Absolutely. So I'm all perfectly fine with that reference, and it has to be, secured to the cabinet. And I'm going to assume that's what you're talking about because you're in 312 and that's dealing with cabinets, cutout boxes, and meter socket enclosures. If we were dealing with a junction box, things like that, device box, whatnot, totally different. You got to go with 314. Okay. All right. So assuming that, and now the holes in the panel, we're assuming like knockouts. So you have knockouts that take place. Then 110.12 is going to be a reference. So if we're talking about just the holes, right, the round holes that you would typically knock out to take in a cable, whatnot from that, then you're absolutely right. 110.12 unused openings. So it's 110.12a, and I believe that you stated A, and that's perfectly correct. Unused openings, and they have to be plugged. The only other one to keep in mind is if you happen to have any of the knockouts, for example, for where the breakers go, then you can go look at 408, and if you look in 408 for panel boards, then I believe you have also some allowances in there as well that you have to be aware of. So let's see here if I can find that, just to be sure. Let's see where it would be here in that value. Let's see. Now that would be under the general rules in 408, and that was under 408.7, which says unused openings. It says unused openings for circuit breakers and switches shall be closed using identified closures or other approved means. Other approved means whatever the HJ is happy with. Okay, it's very broad, but there you go. That provide protection substantially equivalent to the wall of the enclosure. Now, I'm going to be honest with you. I've had some people say the little plastic inserts are not equivalent with the metal wall, and inspectors give people a bunch of gripe over that. But just remember that other approved means, if it's an actual plug that goes in it, plugs the opening for the circuit breaker. If they're made, they're listed, you buy them, manufacturers make them for their panels, then I have no problem with it. So it should be something that's approved. But again, I have heard rumors that people say we don't consider it substantially equivalent. Okay, to each his own. Each his own. All right, but that's for the breaker. So you're right, 110.12a is going to cover the openings like KOs. And then you remember if there's any breaker slots missing in the front, then you could cite 408.7. If there's no breaker openings, then you don't need to worry about that one. I just figured I'd throw that one in there as a little extra in case you run into that. All right, what's next? Okay, number 8 says neutral and grounds under the same screw, 408.41. All right, so let's address this one here. So 408.41. Now this has to do with grounded conductor terminations. That's your neutral. That's your could be a neutral. It's always grounded, but could be a neutral. Could be white. Could be gray. Could be any color other than green with 3 white or gray stripes. You know, there's different things. So that grounded conductor is based on 408.41. It is 1 conductor per terminal, per lug. Now, your panel might actually say that it allows up to 2 equipment grounding conductors to share a lug as long as they're of the same size or gauge. So I can have 2 14s for the equipment grounds. I could have 2 12s for the equipment grounds. But you can't take an equipment ground and a grounded neutral conductor together under one lug, even if they're both the same size. You couldn't do that. You can't twist them together and then try to put them under the lug. No, because 408.41 says you can't do that. Now, this is kind of one of those things where it has been in the code long before this was added years ago. It was in 110.3b where the manufacturers on that legend will tell you how many grounded conductors you can have per termination. And in that same legend, it might again let you have multiple equipment grounds under one terminal as long as they're the same size. But that's okay because that's permitted because of the equipment grounds. You wouldn't have a 14 gauge and a 12 gauge equipment ground going under one lug because once you tighten it down on the 12, since the gauge, the circular mills of the 14 is less than the 12, it's not going to make good contact with the bus. It's going to be loose. So you don't want that. So they give you rules for that. But many years ago, 110.3b, the manufacturers didn't allow you to do more than 1 grounded conductor per terminal. So all the code did a couple cycles ago is bring that into the code under 408 for switchboards, switchgear, and panel boards and incorporate this in there. Now, this rule is dealing with a panel board, by the way, because it is in part 3, which is dealing with panel boards. So very germane to the panel board application. And it just tells you that I can only have 1 grounded conductor per terminal. And it's been around a long time. So it's not new, but that's the reference that you would cite. So you're absolutely right. 408.41 is perfectly fine. Now, you're talking about the sub panel or the remote distribution panel downstream. You say, number 1, the sub panel with knob and tube connections to it 394. Okay, so let's look at this real quick and be able to answer. So 394 is the article that deals with concealed knob and tube. Some of you probably have never seen it before, never run into it before. Again, it predates most of us. It way predates me, even though I'm in my 50s. It's way before I would, trust me, I didn't work with any of this. Have I encountered it in jobs? Absolutely. Luckily for me, most of the time when we encountered it, it was a gut project and we were just gutting it out and they just took everything down to the studs and we just got rid of it and just rewired the building. There are occasions as well where we were able to do the receptacles in a house that had knob and tube, but we were able to salvage the lighting portion and retain the knob and tube. but the receptacle portions of the house, in other words, they opened up the sheetrock halfway down, and we just did the receptacles and things like that. It was okay in our jurisdiction to do that, and we would connect it into the existing knob and tube. Got to be careful because the whole concept of a knob and tube system is like a big shared neutral. So got to be very careful. But anyway, I'm not here to tell you how to do your thing. But you just have to be real careful. Now, knob and tube is still permitted for extensions of existing where you might have the knob and tube. It is also permitted by special permission. The thing is, nobody's going to install it today. Nobody can find it today. There's way more uses not permitted than there are permitted. And the only application for permission under 394.10 is for extension of existing installations into elsewhere by special permission. Special permission means somebody, AHJ, is going to have to give it to you in writing. Okay? All right. Enough of that part. So to answer your question, you have a new remote distribution panel with knob and tube connections. Okay. So it might be that this was existing wiring. They added a remote distribution panel based on the move. Maybe they had to move the existing panel and it had knob and tube, and they don't want to redo the branch circuits. But now it's just easy to turn this into a remote distribution panel. Maybe, I'm just speculating what could have happened here. So if that's the case, those knob and tubes were existing. They were still there. Okay. Now the rules you're going to look at, because it seems to me that after that you also state wires placed with no connectors 312.5C. That's your next question. I am not sure, since you say wires and not cables, because 312.5C deals with cables. So that is true if you have cable assemblies coming in. Now, when it comes to knob and tube, you really need to be looking at 312.5B. And this assumes that we're talking about bringing that knob and tube into a cabinet. Now, for those out there who just wanted the reference, if I was actually bringing knob and tube in for junction boxes and device boxes downstream on the branch circuits, then the rules of how we would take it into a box and all that are covered under 314.17B if we have metal boxes, for example. Okay, and you do get some rules for how you would do that and cover it. So if you're dealing with the non-metallic boxes, then you would follow 314.17C, and it gives you the different rules, right? We're assuming that's not what we're talking about here. Because of the reference to 312, we're talking about a cabinet. So in the cabinet, you're going to be following, if knob and tube is your concern, then it's 312.5B, and that gives you some direction there. It says, where metal enclosures within the scope of this article are installed with messenger support wiring, open wiring on insulators, or concealed knob and tube wiring, it says conductor shall enter through insulating bushings or in dry locations through flexible tubing extending from the last insulating support and firmly secured to the enclosure. Okay, so you're going to have to get it into the enclosure. I would think you would still go. How I would do it is I would probably take it through a non-metallic clamp fitting and take the tube that the wire runs in through the clamp into the cabinet, extending into the cabinet, and then tightening the clamp just enough to secure it. Not over tightening, not being crazy. Okay, that's probably, and that would pretty much get you where you needed to be on every application. No, I wouldn't just run it through an open hole. And again, it's an open hole. So some people can argue, well, a non-metallic sheath connector is only for non-metallic sheathing. Well, I would argue that, well, this knob and tube conductor is about as good as you can get. It's a non-metallic. And so again, to each his own. And again, you can either take what I say as a grain of salt or go hunting for that mystery connector that's designed just for knob and tube. If there's one out there, you go for it. But I'm just giving you my interpretation of how I would be acceptable to this in meeting these rules. So your reference, if it's a cabinet that knob and tube's coming into and it's basically coming through a big open hole, then I would cite 312.5B for that. If you have other cables that are coming to the cabinet that are not secured to the actual cabinet, then I would cite 312.5C for those cables. Remember, knob and tube, the individual wires, that is not a cable. Okay, and 394 will make that real evident. Okay. Hopefully that answers that question. I think that answers the very last question there as well, because he says wires placed with no connectors. And he cites 312.5C. So again, I'm assuming that's a cable, and that would be correct. If it is the knob and tube, then I would cite 312.5B and go from there. All right, so hopefully that has answered all of your questions that you had on this episode, and then we're going to cut it. This is a 40-minute episode answering all of these different questions. If I didn't answer it to your satisfaction, you can always do a follow-up over at paulabernathy.com. Anybody else has any other opinions on this episode, just cite the episode in the title of this episode, and you can put that in the paulabernathy.com portal and send me your reply. And you know what? If I feel like you're correct or it's going to help educate others, then I will do another follow-up on that. Okay? All right. Till next time, folks, stay safe. God bless, and look forward to your future questions.